12 and welcome to Purple Mountain Maths. We are doing the 2025 HSC paper for Mathematics Advanced. This is part 7, question 23 and 24, worth 9 marks. Question 23. In a flock of 12,600 sheep, the ratio of males to females is 1 to 20. The weights for the male sheep are normally distributed with a mean of 76.2 and a standard deviation of 6.8. In the flock, 15 of the male sheep each weigh more than X. Find the value of X. Pause here to try it yourself. Okay, so we know that this is a ratio question. M for male, F for female, T for total. We know that this is 1 is to 20 is to 21 parts in total, and the total is 12,600. So 12,600 divided by 21 is 600. So I must have multiplied each of these by 600. 600, 12,000, and 12,600. Okay, so now we know there are 600 male sheep. Okay, we also know that they are normally distributed. We know that mu equals 76.2. We know the standard deviation equals 6.8. So the mean is 76.2. We know that 1 standard deviation is here. We know that 2 standard deviations is here. So that's a standard deviation, that's a standard deviation, and so on. All right, so let's figure out what proportion are we interested in. 15 of the 600 15 on 600 is 2.5%. Okay, so we know that in a normal distribution, 95% of the scores lie within 2 standard deviations, and the other 5% are beyond that. So 2.5% this way, 2.5% that way. So 2.5% means that we are at 2 standard deviations above the mean. So the mean plus 2 lots of the standard deviation in our calculator, 76.2 plus 2 lots of 6.8 is 89.8. So X equals 89.8 kilos. Okay, part B. The weights of the female sheep are also normally distributed but have a smaller mean and a smaller standard deviation than the weights of the male sheep. Explain whether it could be expected that 300 of the females from the flock each weigh more than X, where X is as above. Okay, so let's figure out how many they're talking about proportionally. From above, there exists 12,000 females. 300 over 12,000, that is also 2.5%. So we're also interested in the top 2.5% of females. Now let's use the information they gave us. We know that at 89.8 kilos, which was the value of X, only 2.5% of males were above that. But we're also told that the females have a smaller mean and a smaller standard deviation. So not only is the female mean lower, it's also a tighter distribution. So it's like that. So females are also normally distributed with a lower mean and standard deviation. Therefore, its curve is lower and tighter than the males. So the top 2.5% of the women are going to occur at a much lower X value than the original X. So no, it is not possible for 300 of the females to weigh more than X, which was 89.8 kilos. Question 24. The graphs of y equals e ln x and y equals ax squared plus c are shown. The line y equals x is a tangent to both graphs at their point of intersection. Find the values of a and c. Okay, so let's see what we know. Because y equals x is a tangent, then m equals 1 at this point. Let's differentiate. Consider the curve y equals e ln x. When I differentiate that, I'm going to get e times 1 on x, which equals e on x. We know at the intersection point that is 1. M equals 1. Therefore, e on x equals 1. That implies that x equals e. So we know that this is the point E, E. Okay, now let's consider the parabola. Y equals ax squared plus c. Let's differentiate that and we'll get 2ax. But we know that m equals 1 at this point. So we know 2ax, and x is e, equals 1. Therefore, a equals 1 on 2e. And we know e comma e is on the parabola. So let's substitute that in. E equals a times e squared plus c. So e equals a half of e plus c. Therefore, c equals a half e. So our two answers are a equals 1 on 2e and c equals a half of e. That's the end of part 7. Thanks for listening to Purple Mountain Maths.